In this video, we're going to learn how to factor quadratic expressions and add to the tools that you have in your factoring toolkit. So far, the only way we've learned to factor something is to look for a greatest common factor. Let's add to those tools today. Before we begin, we need to know what a quadratic expression is. A quadratic expression is a polynomial where the highest power of x, or it could be any other letter, but we use x quite often, is a 2. Okay, and that's what makes it quadratic. So that means we could also have an x term if we decrease the power of x by 1, and we could have an x to the 0, which means no x at all. So we could have a constant value, I'll call it c. Now we can have values in front of this x squared term and this x term that are not 1, or they can be 1 as well. Today we're going to focus in on when this is a 1 and this is any other value, which we'll call b. So this completely simplifies into asking how can we simplify a polynomial expression, or specifically a quadratic expression that looks like this. So first I want to have you realize that expansion and factoring are just opposite processes. And so a quick little example to illustrate that. If we have x plus 4 times x plus 3, we have two binomials being multiplied. We know from previous lessons that this means we're going to enact our FOIL processes to expand them, to make sure that each term gets multiplied by the other terms in the other binomial. So if we do our firsts, we get x squared. If we do our outsides, we have 3x. If we do our insides, we have 4x. And if we do our lasts, we have 7. And we see in the center here that we have some like terms that can be collected to read 7x. And sorry, it's early this morning. Let's make 4 times 3, 12 today, shall we? Instead of 7. There we go. That looks a little better. All right, now, this is called expand and simplify, because we did all the multiplication, and then the simplify means that we're going to look for like terms. But if you were asked to factor, what that means is that you are actually starting with the answer, which is x squared plus 7x plus 12, and being asked to go back to the binomial form instead. So we can see then that expand and simplify and factor are just opposite processes. One gets you to the quadratic expression, the other one starts with the quadratic expression and goes back to the binomial form. Okay. So then the question today becomes, how do we do this? How do we go from here to here? So we need a strategy. So what we're going to do is we're going to set up something called a T-chart. It stands for thinking chart, but I call it T-chart for short. And this is the general thing to consider for the next couple of lessons. I'm going to put an A in front of here because A can also be bigger than 1. It can also be smaller than. We'll be studying that much later. But today's focus is when A is equal to 1. But I'm going to set up the general idea here for all quadratic expressions so that you have it. If we could think of factors or numbers that give us A times C, and if we could think of what those factors add to get, we could get the sum, which would be equal to our B value. So if we go back to the one we were asked to factor, and let's say we hadn't done this process first, we were trying to come up with this, here's what we would do. We would say to ourselves, what are two numbers that multiply to give A times C, or 1 times 12? And what are two numbers that add to give the B value of 7? So if you don't know those right off the top of your head, you can start brainstorming with, well, I can get 12 easily by doing 1 times 12. I could also get 12 by doing 2 times 6, 3 times 4, and then I get down here to 4 times 3, and I end up sort of repeating myself. Okay, so I just started with the number 1. I saw if it was even, I could do 2, and so on. Let's add these up. So 1 plus 12 is equal to 13. Well, that's not equal to 7, so this pair must not be the right one we're looking for. 2 plus 6 is equal to 8. That doesn't equal 7, so also that's not the pair of terms that we're looking for. But 3 plus 4 does equal 7. So what that means is that we can take this and we can rewrite it as x in the first binomial and x in the second binomial, because when the firsts get multiplied, they have to be x squared. And then we can put our values of 3 and 4 in either spot. I can do plus 3 here, plus 4 here, or I can flip it around like I had up here. But it's the same result, just changing the order of those factored terms instead. So I'm going to leave this here so that we can see how it works. And let's do another example. Let's factor, and it says, if possible in your notes, the following quadratic expressions. X squared plus 4x plus 6. So my little thinking chart I can sometimes just put off to the side. What I'm looking for are two numbers that will multiply to give a times c, or 6, and that will add to give the b value that is here, which is 4. So what are some things that multiply to give 6? Well, I can do 1 and 6, I can do 2 and 3, I could do 3 and 2, but that's the same. So what are the sums of these pairs of factors? Well, 1 plus 6 is 7, and 2 plus 3 is 5. So that means that there aren't any terms that meet these criteria, and we could say that this is not factorable. Okay, and it's that simple. Let's try another one. Let's do x squared minus 16x plus 15. So again, I like to put my little thinking chart off to the side. Two numbers that multiply to give a times c, or 1 times 15. And that add to give negative 16. So let's begin with the things that multiply to give 15. I have 1 and 15. I can't do 2 because it's not even. I can do 3 and 5. And I want to find some that add to give 16, or negative 16. Now, if two numbers add to give negative 16, but they multiply to give a positive number, what does that tell you about the signs of these two factors? Well, it tells you that they must both be negative, because two negatives multiplied give a positive, but these two negatives added together give us a negative sum. And no matter how I work the 3 and the 5, I will never get them to add to give negative 16. So it looks like I have found my pair of factors, more specifically these two here, which means I can write this in factored form as x times x, because x times x gives me x squared, and I can put the negative 1 and the negative 15 in the other places. Negative 1 and negative 15. It doesn't matter which order. If you do a quick mental check, you should, if you FOIL it out or expand it, do the opposite process, get the question that you started with. So first give x squared, outsides give negative 15, and the insides give, negative 15x. The insides give negative x, so that's a total of negative 16x. And then negative 1 times negative 15 gives positive 15. So I know I've done them correctly. Let's try one more before we change it up a little bit. Let's do x squared minus 2x minus 35. And because there's a 1 here in front of the x squared, again, I know that the two binomials that multiply to give this quadratic expression must also both begin with x. Let's add our little thinking chart on the other side. I need two numbers that multiply to give 1, or a times c, or 1 times negative 35. I'm going to do that in my head this time. I just put that there. And they have to add to give the b value here, which is negative 2. So I can start with 1 and 35. Now what's interesting is that if they multiply to give a negative product, that means that one of these must be negative and one of them must be positive. So if I try putting the negative with the 1, and the negative with the 35, those are going to give different sums. So I'm going to explore both of those options. Now, do either of those add to give negative 2? No, they don't. Okay, let's continue on. So 2 is not a prime factor of 35. 3 is not. 4 is not. 5 is our next one. So we have 5 and 7. And again, we can put the negative with the 5, or we could put the negative with the 7. Again, product-wise, they'll both give negative 35, but adding them together will be different. Here I have more positives than negatives, so I get plus 2. But here I have more negatives than positives, so I end up with minus 2. So there's the pair that we're looking for right there. And I can just write them in. Plus 5 and minus 7. And again, if you apply FOIL to this, you should end up with what's given up here. So it's a good way for you to double check. Okay, our last example is slightly different. It says, let's factor this quadratic expression. You might go, whoa, that looks really different from the ones we just did. And you're right, it is in a couple of different ways. So the first thing I want you to see here is that it is a quadratic expression because it does have a decreasing power of x. It goes from x squared to x to the first, x to the 0 is equal to 1, so it does meet that criteria. But it doesn't have a value of 1 in front. So what we're going to do in this example is combine all of your factoring tools together that you have so far. When you are asked to factor any type of polynomial, the number one step always, always, always is to ask yourself, is there a GCF? And I failed to do that in the previous examples, but I hope you recognize that because there was a 1 in front of one of the terms, there was no GCF numerically, and because the powers of x were all different, in fact this one had no x's at all, there's no literal piece to pull it as a GCF either. So let's look through this. Is there anything that they all have in common numerically and literally that can be taken out first? Well, when I look at the values that are in front of each of these terms, I notice that they are all multiples of 3. So I can take out a factor of 3. If I do that, I'm left with x squared plus 3xy minus, more early morning, having a hard time with the mental math. Let me try it again. Here we go, we get 18. That's better. Sorry about that. Okay. I look back in here and I just make sure that I took out the GCF. Numerically, I'm down to a 1 here, so I know I can't take out anything else numerically as a GCF. And then none of these all have an x or a y in them, so there's no literal piece. All right? So then again, I recognize this is a quadratic expression, and I'm going to need a little t-chart off to the side. I'm going to need to come up with two numbers that multiply to give a times c, or 1 times negative 18. And I need two numbers then that add to give the middle term of this quadratic expression, or positive 3. So let's begin with factors of 18. I always like to start with 1, just so that I can have a sequential way of eventually finding the answer, if my times tables aren't so quick and easy to me. Because I'm multiplying to give a negative, one of these has to be negative, one of them has to be positive. Now clearly there's no way either of these can add to give positive 3. Let's now look at 2 as a factor. I use 2 and 9. I can put the negative with the 2, the negative with a 9, but again, neither of these are going to add to give positive 3. I then look to, how about 3 as a factor? 3 and 6. Let's let one of them be negative and one of them be positive and try both options. When I add these together, I get positive 3. Down here, I get negative 3. So here are the two factors that I want to include in the answer of my polynomial. So this is equal to 3 times, again, we can start each of these with an x because The first, when multiplied, will give x squared. And then we can put our negative 3 and our negative 6 in here. Negative 6. And if you were to do the full expansion of this, of course, doing the binomial first and then distributing the 3, you should end up with the question that you started with. So factoring is the opposite of expanding. All right. Try out the questions for practice, and if you have any concerns or need some more clarification, let me know. But please engage and embark in using this T-chart to help you come up with the 2 factors that are needed for the final answer. It will come in really handy now and in future lessons.